Hey Abby, this video is for you. So what I'm using is a review question for the quiz, and it is based on this exponential equation. What we're trying to find out is the number of years it would take for some radioactive material to get to 45 grams. And so what we're doing initially is typing in 45. When is that equal to, or how many years will it take for this 90 grams to reduce to 45 grams? So just rewriting this equation with the 45 in place of that mass value. So negative T over 20. Okay, now the first thing you would do is divide by 90 on both sides to get this exponent expression by itself. And what you'll come to is 0.5 equals 2 raised to the negative T over 20 power. Well, if you want to use logs, you can solve this that way, or we can go to the calculator and type y equals 0.5 as your first equation and y equals 2 to the negative T over 20 power for the second equation. So now I'm going to show you what that looks like on the calculator. So I've already typed it in the calculator so you can cleanly see over in this right side, the first equation is 0.5, the second equation is 2 to the negative x over 20. Now I'm going to zoom out so I can use the functions on the calculator. So sorry that things are getting smaller, but I want to make sure that I can use the calculator. Okay, so the next thing is to do second trace. Within these commands, we can find their intersection. So go to number 5, and you're going to have to go through a couple clicks. The first click says, first curve at y equals 0.5. Yes, hit enter. Is the second curve at y equals 2 to the negative x over 20? Yes, hit enter. And now we're going to guess. So where do you think the curve and that line are going to intersect? I'm going to go to the right a little bit, maybe around there, maybe close to 15. We'll see. Hit enter. And that tells us the exact number of years. So it's going to take 20 years for that substance to get to 45 grams. So let me repeat that. So the first thing you do is you type it in your calculator, type one part of the equation, and then your equation model on the other side for the other equation. Second, trace. We want to find their intersection, so number 5. I'm going to zoom out a little bit more. Oops, shoot. Let me back up. So second, trace, 5. Yes, this is the first curve. Yes, they moved to the second curve, and I'm going to go to one that I know is not the intersection to show that I'm just guessing, but it brings me to the exact value of 20 for that intersection. If you have more questions, please let me know. Thanks for speaking up.